Got a 5.
I didn't. I got a countdown that went 6, 4, 3, 2, 1. All right, here we are. Hello. If you've logged in live to watch us, sorry. But anyway, here we are, ready to roll. And I believe, Fred, that our patrons now get the live edition of our recording session too, which is fair enough, seeing that they are paying through the nose to support us.
Absolutely. Good on you.
Okay. Let us begin with the TikTok promo. Are you all set?
Yeah, I think so.
Because we're going to do it a bit different today. We're going to do 4 stories and 2 questions instead of 2 stories and 2 questions.
I'll cram them in.
Yeah. Okay.
If I can remember them.
Yeah. Well, if you miss one, I'll just pretend we're not doing it. Okay. Here we go. In 3, 2, 1. Hi there, Andrew Dunkley here, the host of the Space Nuts podcast. Hope you can join us on the next episode because we've got a lot to talk about. And joining me as always will be Professor Fred Watson, astronomer at large. What's coming up, Fred?
Absolutely packed news edition of Space Nuts. We're going to talk about a micrometeoroid that dinged the James Webb Space Telescope. We're going to talk about NASA introducing a study to look at unidentified aerial phenomena. Then we're going to Pluto because we're going to talk about an occultation of Pluto, which has produced some interesting results. And finally, a record breaker, the fastest growing black hole that we know has just been discovered by Australian astronomers.
Wow. Gee, that doesn't sound too nice, actually. If it's a fast-growing black hole, we know what they're all about.
Yeah. It's all right. Off. It's all right.
Well, that's good. We'll also be answering a couple of questions. Brett wants to know about astrophotography, and Fenton is, you must have woken up in the middle of the night, Fenton, trying to figure this one out. The ratios of elements as you move away from the sun. Not the first thing I think of when I wake up in the middle of the night. But anyway, we will cover all of that in the next episode of Space Nuts. Hope you can join us for episode 309. Download from your favorite podcast distributor. All righty then. Gee, that was almost flawless. What are we doing? Good grief.
Maybe it's good having a week off, Andrew.
Yeah. Well, we actually haven't spoken for 2 weeks.
That's right. It's 2 weeks since
because we've both been gallivanting around.
Yeah, I must tell you. Sorry, I know this is going out live to the audience, but in Norfolk Island, didn't you used to broadcast to Norfolk Island? From
Dubbo? It was a quirk of the satellite system, but the station here in Dubbo that I was working at for 22 years and managed for the last 8 years of my career at the ABC was the last link in the satellite chain system. And as a consequence of that, we fed what was called the Southeast Regional Radio Satellite Network, SERR we called it. And that meant that anybody who couldn't pick up a local station could get a satellite feed of ABC local radio, and they just got the default broadcast, which was us. So we broadcast to tiny little towns in the snowy mountains that couldn't pick up local radio. Yeah. We broadcast to Norfolk Island. Mm-hmm. We were broadcasting to Lord Howe Island for a while until they got a translator from the Mid-North Coast station. But Norfolk Island basically was a permanent part of our network out of Dubbo. So we used to have this joke that Dubbo was an outer suburb of Norfolk Island. Gosh, it was fun. And I got to go there one year, and they treated me like a god. It was really
they would. Well, they still remember you, Andrew.
Do they?
Because last week when we were there, Marnie and I did a bit of a wine tasting at the Two Chimneys Winery.
Wow.
And the gentleman there, delightful gentleman who actually lived for a while in Gunnedah, he said, in northwestern New South Wales, certainly not far from Coonabarabran and not far from Dubbo. But he said he remembered a Christmas broadcast that you did, where you interviewed a lady on Norfolk Island, and it was on Christmas Day, and you were saying to her, so what are you doing? What are you cooking? Are you doing something special for Christmas dinner? And she said, no. You couldn't get you just struggle to get answers out of her. And so you're saying, do you not do something nice and special for the family? No, I don't. What happens on Christmas Day? Well, my husband's doing the cooking, and I've got a migraine, so I'm off to bed. That was the end of the interview.
Oh my gosh, I don't remember that.
Well, he did
because it was a forgetful interview. That's probably
yes,
why.
it probably was one you wiped from your.
Oh gosh, I've had all sorts over the years. Some have been horrendous.
Yeah.
Done some good ones too, but you tend to remember the bad ones more.
Yeah.
I don't know why.
No, you've saved the best till last, Andrew. That's what you've done.
Yes, I think so. All right, let us get started. And
better get these stories up, haven't I?
Yes. Let's do. I'll do the dry intro and then play the music, and we should be good. Oh, where's the music? There it is. Hang on, I'll just hover there. All right, here we go in 3, 2, 1. Hello, thanks for joining us on Space Nuts. It's all about astronomy and space science. My name is Andrew Dunkley, your host. And on this week's episode, the James Webb Space Telescope has been hit by a rock. So you shouldn't let kids play near it. That's the bottom line. NASA has some thoughts on unidentified aerial phenomena. We're going to look at the occultation of Pluto. And there's a fast-growing black hole in our neck of the woods. Well, not really our neck of the woods, but it's in our galaxy universe. It's in the universe, that's for sure. We're going to find out what it's all about. We'll also answer some questions from Brett about astrophotography and Fenton about the ratios of elements. It woke him up at night, and he had to ask. Thanks for that, Fenton. That's all to come on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me again is the good Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. How are you doing?
I am well. Yes, you are too. Yes.
Oh, thank you.
Now, you've just come back from a trip to a little island, which was a former penal colony of Australia called Norfolk Island, which is, by sheer coincidence, a place that I know well because when I worked for the Australian Broadcasting Corporation, my station was the default satellite feeder to Norfolk Island. So I broadcast to Norfolk Island for 22 years.
Well done.
So it's about the only place in the world where I'm minusculely famous.
No, they still remember you, Andrew. We had a conversation about you at a wine tasting, actually, in a delightful winery called Two Chimneys, just to put a plug in for it. Norfolk Island, a lovely spot. We were really enchanted with the island itself. All the more so because within 2 hours of arriving, completely unexpectedly, we ran into somebody I used to work with who I didn't know was at Norfolk Island.
That's funny.
She came up to me and said, "Didn't you used to work for the Square Kilometre Array?" And that's kind of nearly true because that's certainly part of what we do at the Department of Industry. Yeah, so and of course I remembered, and we had a lovely morning tea. So. Shout out to you, Amber. Thank you very much for that. If you listen to Space Nuts,
it's a fascinating island, so full of history.
Yes, indeed.
And of course, if you know about the mutiny on the Bounty, and of course, some of our international listeners will be aware of that story. That's where they all ended up.
Yeah, and we happened again completely by chance, Andrew. We happened to be there during the week when they celebrate Bounty Day, which was last Wednesday. Yeah. So there's everybody the local islanders dress up in 18th century clothes and do this kind of reenactment. They lowered a boat to which I think was meant to land on a ramp, but the sea was too rough, so they sort of hauled it back out with a crane. But yeah, it was a delightful experience. Lovely thing to see. And as I said, completely by chance. And
it's the place where I caught my one and only shark when I went.
Oh, really?
Yeah, fishing. Yeah, caught a bronze whaler. Wasn't a big one, but it was a hungry one.
All right. Okay.
And we had it for dinner.
So.
Yeah, we did.
Okay.
Yeah.
Wow.
Yeah, no, I have great memories of Norfolk Island on and off the air. We better get down to business,
Yeah,
Fred. We've got a lot to talk about.
Yes,
First up, let's talk about this situation with the James Webb Space Telescope, which got hit by a rock, only a tiny little rock. But obviously, it's something that could be very concerning if it causes any damage. But in this case, it doesn't sound like it's going to create much of a problem, hopefully.
That's right. So it's I think when you design something like a space telescope of this kind, especially one with such a large mirror collecting area, it's a 6.5 meter diameter mirror made of these 18 hexagonal segments. The design itself has got to include catering for the energy that might be imparted by an impacting micrometeoroid. And indeed, it's all worked because it was sometime in late May when this event happened. Apparently, it's the 5th time it's been dinged by a micrometeoroid, but this is the largest to date, and it was enough to throw one of the mirror segments slightly out of alignment, but not anything that couldn't be very quickly recovered. So they've sort of got over it. NASA's quote was, "After initial assessments, the team found the telescope is still performing at a level that exceeds all mission requirements." So it's good. The last thing I heard, and this is a week or so ago, that a readjustment was in progress. I haven't heard any bad news that there was any serious damage or anything. I think it was just a slight knock of the a slight misalignment, the kind of thing that if it was an earthly telescope you might do if you walked past it clumsily and your elbow got in the way or something like that. Yeah. So we're in good shape, I think.
That's good to hear. It does suggest, though, that there's a lot more debris out there than you would ever imagine if something as small as the James Webb Space Telescope is getting clobbered a few times.
Yeah, five times, that's right.
And I imagine it's going to get hit again at some stage.
Yes, it will. I mean, what will have happened when the telescope was being designed, Andrew, is we've got pretty good estimates of what I guess would be called the flux level of micrometeoroid particles. And so the engineers would have built all this in, putting upper limits. I mean, if something the size of a potato hit it, because the speeds involved up to 30 kilometers per second, I guess that could be fatal for one of the segments. But I think most of what we're talking about are really particles that don't carry much energy, although they clearly have some energy because of their velocity.
Yeah, they've got momentum for sure.
Not much mass. Yeah.
Yeah. Well, it's good that it's survived and recovered. And when are we going to start it officially in mission mode?
It's next month, July. I'm not sure of the date. We'll see plenty of media releases because there'll be some, I think, quite spectacular images that they will provide up front. We know it's working really well, so there's every reason to expect we should see something quite breathtaking.
I hope so. Can't wait. That'll be big news. All right, from the James Webb Space Telescope to unidentified aerial phenomena. Now, we've been talking about these lately because they got to a congressional hearing level. So government officials and Defense Department officials have been discussing these things, and they're quite open about the fact that they don't know what they are or who's responsible, whether it's some covert operation by human beings or not, remains to be seen. But NASA has now spoken out about these.
Indeed, that's right. In fact, they've done more than spoken out. They're launching a new study. This was an announcement last week. So it's an independent team that's being set up. And I think what they're going to do is just assess how much information is publicly available and how much more you might need to understand what these sightings are all about.
Yeah.
So it's, and in fact, there is yeah, of course, there's always a risk when you find NASA investigating what we used to call UFOs, and that has been usually assigned to the sort of fringe activity of what you might call the human experience, people who think we've been visited by UFOs and things like that. So that's why I think they have progressed fairly cautiously with that. So their mission science, it's their science mission chief, a gentleman by the name of Thomas Zurbuchen. He kind of acknowledged this, that he says this traditional scientific community might see NASA as kind of selling out by venturing into this topic, but he disagreed, and he's quoted as saying, "We're not shying away from reputational risk. Our strong belief is that the biggest challenge of these phenomena is that it's a data poor field." In
other words, we don't know what they are.
We don't know. We don't know anything. So this is a sort of first step. It's a relatively, for what it is, it's pretty inexpensive.
I'm going to save that one up, because if my wife says, "Do you know what this is?" I'll say, "That's a data poor field."
A data poor field. It is a good one, isn't it? Yeah. So there's an astrophysicist involved, and actually David Spergel. He says the only preconceived notion going into the study is that the UAPs are likely to have multiple explanations, which I think is actually one of the conclusions that was in that report that came out last year. The the initial report that was publicized by the intelligence agencies in the US, that essentially that it's very likely there'd be many different explanations. He says, Professor Spergel says, we have to approach all these questions with a sense of humility. I spent most of my career as a cosmologist. I can tell you we don't know what makes up 95% of the universe, so there are things we don't understand. Well, that's right. And, this is one of them. So it's not just, it's not, I guess, of the many things that we don't understand, this is one of the most provocative.
Yeah, and the fact that it's been seen multiple times, like hundreds of times, people have witnessed these phenomena, and their speeds and their maneuvers are beyond anything we're capable of in traditional aircraft. Naturally, people are going to default to aliens and UFOs from outer space, but the fact that such big organizations and significant people within government and the military are speaking out about this says that this is serious. This is no joke. It's not a someone trying to pull the wool over our eyes and have a bit of fun. There's got to be something to it. And what I think they're trying to do with this study is gather as much data as they can, and they'll want to be hearing from anybody and everybody who's witnessed this, because it's been seen out over the Pacific Ocean mostly by military aircraft, but also civilians. So they're going to try and get as much info together and study it to see what they can learn, and hopefully come up with some kind of theory at the very least. I'd love them to go all the way and say, we know what it is. It's those guys who just got their driver's license in California, and that'll be it. I've got a feeling it won't be that. But...
No, I don't think it'll be that. But yes. One of the theories is that it's another arm of the US government which doesn't talk to anybody and wants to keep these things a bit undercover. Which, if that was the case, why did they fly them next to US military bases?
That's right.
Anyway, look. I think it's a great step. Actually, I think it's something that is of interest to everybody, and we might indeed learn something that we didn't already know.
Well, if they bring Fox Mulder into it, he'll figure it all out, I am sure.
Very good.
He's always good at that. I've just got a text from my wife, and she's asked me what this debit is on our back account. I've just replied, hang on, that's a data poor field.
It's gone into an unidentified aerial phenomenon.
Yes, indeed. Well, obviously there'll certainly be more to tell about this story going forward. So we'll keep an eye on it, and if they come up with some sort of idea or at least some basic theory, we'll let you know what they think. But at this stage, it's all up in the air. Boom, boom. Oh dear.
That was terrible, Andrew.
It was horrible, wasn't it? Yeah. Okay, we'll take a break. This is Space Nuts with Andrew Dunkley and Fred Watson. You got to do dad jokes.
No, of course you do. That's why people listen to it.
Yeah.
But it's my role to criticize them as well. So that's
absolutely yes. Yeah. It's a legal requirement.
Indeed. Now,
next one. Which one did you want to do next? The occultation or the black hole?
Yeah, I think if we can do the occultation, that would be very good.
All right, that's easy. Okay, and here we go in 3, 2, 1.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, I don't profess to...
Roger, you're loud and clear here also.
Space Nuts.
Thank you for that. Now, Fred, I don't profess to understand the next story in any way or form. It sounds too complicated for my feeble brain, but scientists in Australia are running around the desert looking for Pluto, and it's got something to do with occultation.
Indeed. It's a really great story, actually, is this. And I think I seem to remember hearing some, reading some correspondence about it when it was in the planning stage, probably a year ago. Let's just talk about the phenomenon that was being observed. It's an occultation. Occult has a different meaning these days, but the word means to occult is to hide. And so that's what it's about. So I guess the occult is the hidden, but an occultation is when one celestial body hides another. And you can actually use these to learn stuff. Think of it this way. For example, if you have an asteroid, which you only see, in a traditional telescope as a point of light. Some asteroids have been mapped by radar, but most of them, all we know about is their brightness, and their that gives you an idea of how big they are. But if you wanted to sort of map its shape accurately, one thing that you can do is that you can work out when this asteroid might pass between the Earth and another star, a distant star. And what happens in that case is that the light of the star is blocked out by the asteroid. So you get this shadow of the asteroid in starlight passing over the Earth's surface.
Wow.
And so traditionally what people have done is strung out observers along this path where the shadow is going to move, and as many observers as you can, both along the direction of the path and at right angles to the path. And then these observers can time accurately when the star disappears and when it reappears. And by doing that, you can actually get a very accurate calculation of the shape of the asteroid. So that's the sort of traditional use of occultations. But here we have something slightly different with the planet, with the dwarf planet, Pluto. I've been around for a long time. It's 2006 is pretty recent in my understanding or knowledge or friendship with Pluto, let me put it that way. It is a dwarf planet, though, there's no doubt about that. Anyway, the dwarf planet Pluto is, we know, about a couple of thousand kilometers in diameter. So what's happening is that it will pass in front of a star. And so in this case, the occultation observations are not really so much about the shape of Pluto, because we know that pretty accurately from the New Horizons flyby in 2015. But it's about Pluto's atmosphere, because Pluto has this tenuous atmosphere. And what that means is that when Pluto passes in front of the star, as seen from a vantage point on Earth, the star's light dims slowly. It doesn't just switch off, because it dims as it passes through Pluto's atmosphere. And in fact, some years ago, it's probably a decade ago now, I was peripherally involved with exactly similar measurements of Pluto's atmosphere made from the Anglo-Australian telescope when I was astronomer in charge there. And I think they got really good results showing the layering of the atmosphere of Pluto. But there is another possibility that comes from this, and this is what makes this story, I think, really exciting, because if you happen to have an observer right in the center of the track that Pluto is, following across the surface of the Earth, there is a chance that you might pick up, as well as seeing the light of the star dimming as Pluto passes in front of it, you might pick up a bright flash in the middle where Pluto's atmosphere refracts the light around it and focuses light onto the surface of the Earth.
Oh, wow.
So there's the potential for a bright flash. And the reason why we're talking about this story is that they got it. And there's a lovely feature, actually, a good plug here for the Australian Broadcasting Corporation. The ABC's website, they have a very nice piece on this, which is done in what they call their Odyssey format, which is a very image-rich and video-rich format for websites. If you look for searching for the Flash on basically abc.net.au, that's the Australian Broadcasting Commission's website. There's a very nice piece done by somebody I'm privileged to know, a science journalist, Michael Slezak, and they put it together, and it is a very exciting read. And not only that, but you get the video feed from the Flash itself, which is quite an extraordinary thing. This flash of light lasting about a second as this focused beam from the star passes over the surface of the Earth. It's very, very nicely done.
Yeah, it's a great page. I'm just scrolling through it now, and they've got that time-lapse video of the people setting up the
observers. That's right. Yeah,
yeah. It's really quite an impressive display of news, actually, the way they've done it.
Yep.
It makes me wonder, Fred, about other shadows that may be hitting Earth that we are totally unaware of. We don't think about that, but we must be getting hit by shadows all the time. Yeah,
that's right. In fact, every star in the sky is going to produce shadows of objects at one time or another, but we don't think about them because they're not. The only way you can record them is by having a telescope pointing in the right direction. Yeah. So when I was a young astronomer back in the 1970s, Andrew, I was engaged in occultation observations, not of asteroids or dwarf planets, but of the moon. Stars being blotted out by the moon, particularly near its northern and southern poles, because what happens there is, as the moon, if you've got a star that's that the moon's edge is just going to skim as it passes in front of it, this star will disappear and then appear again, then disappear again and appear again because of the mountains on the moon. So it was actually a way of looking at the topography of the moon was to do occultation studies. And I remember being quite deeply involved with that in the Sussex countryside from the Royal Greenwich Observatory a long time ago.
Now, just to get back to Pluto for a moment, they got the flash, but I understand they also learned something about Pluto's atmosphere, and that is, as it moves further from the sun, it's thinning.
I think they got the opposite from that,
the opposite.
if I remember it. Yeah, because you'd expect it to thin. And that was actually one of the reasons why New Horizons was sent when it was in 2006 was when it was launched. And made to be a very fast spacecraft. It was to catch up with Pluto before Pluto's eccentric or elongated orbit took it away from the sun, because the feeling, we've known for a long time Pluto had a thin atmosphere, but the expectation was that as Pluto moved away from the sun, that atmosphere would just freeze out onto the surface of Pluto because it's so cold. But if I'm reading, I can't remember, I read this last week, but I think there was a comment that it looked as though the atmosphere was actually thickening as it moved away from the sun. So that's a really interesting observation. And it highlights the need that, the reason why occultation experiments like this are so worthwhile. It's a lot easier to put together 40 telescopes in the outback of Australia or wherever the shadow is going to pass, than to send a spacecraft to Pluto.
I was about to say the same thing. Yeah, it's amazing what we can learn by not leaving the planet.
Yes, that's right.
We've got the right tools and the right people in the right place.
And a lot of ingenuity, yeah.
Yeah, indeed. Yeah, that's fascinating. All right. Now, another story that we wanted to talk about was this black hole that's been discovered. And this has been described as a fast-growing black hole. And it's seemingly quite hungry. It's also pretty darn big.
Yeah. So yes, it's a supermassive black hole. The yardstick that we use all the time on Space Nuts is the supermassive black hole at the center of our galaxy, which is 4.1 million times the mass of the sun. This one, which is in deep space, so it's not anywhere near our galaxy, but it is 3 billion times the mass of the sun. 3 billion times the mass of the sun. So it's a much bigger black hole. It's a very nice story, again, that an Australian story. Astronomers at the Australian National University, led by Chris Onken there, used Sky Mapper, which is one of the telescopes at Siding Spring Observatory near Coonabarabran, where I used to work. That Sky Mapper does what its name suggests. It maps the sky. And the astronomers were actually looking for what are called symbiotic stars, where you've got two stars revolving around their common center of mass, a binary system, but they're exchanging matter. And that's what they were looking for. But what they found was this distant, very distant object. I think it's, if I remember rightly, it's about 9 billion light years away. It's that sort of distance. We're seeing it at a really quite a large look back time. It's a quasar, and quasars are essentially the supermassive black holes at the center of galaxies, which are very active in devouring material. And this one's turned out to be a bit of a record breaker. So it consumes the equivalent of 1 Earth every second, that's quite an accretion rate.
Yes.
And that's probably why it's grown so big. So the record breaker is that it's the fastest growing black hole discovered in the past 9 billion years. So there you go.
So is it at the center of its own galaxy, or is this one a free roamer?
I think it's odd, isn't it? Because the amount of energy that's coming from the accretion disk around the black hole outshines the whole galaxy. And that was actually what puzzled astronomers when they first discovered these objects, quasars. Quasar is quasi-stellar source, so it looks like a star. But actually, it's got a host galaxy, and often the host galaxies were discovered later around this bright point of light, which was the quasar. So this will have a host galaxy probably, but it's the quasar itself that's been observed, the black hole and its accretion disk.
Yeah, wow. Got a great name too, hasn't it?
Oh, yeah. I don't think we've got time, really, for its name. It's so long. They're calling it J1144 for short. There's a lot more besides those numbers, but yeah, J1144.
Yeah, J1144 7.77-4308559.3.
Oh, that's good, all in one breath.
Yeah, I can't. I need a break.
Yeah.
But that'll be one to keep an eye on, because
I think so. Yeah,
they might learn a bit more about black holes because of its sheer enormity, but its appetite.
Its appetite. That's right.
Yeah, quite fascinating. All right, we will take a break. In fact, from Space Nuts, episode 309, with Andrew Dunkley and Professor Fred Watson. Okay. Now, questions. Where are they? Here we go. Got it. And then the audio question, which is there. Excellent. All right. Well, I'll just hit the next audio bit and we'll carry on.
Why not?
In 3, 2, 1.
0G, and I feel fine.
Space Nuts.
Question time, Fred, and maybe gives me an opportunity to remind people that next week it will be episode 310, and we have generally been, and although we've been a bit slack in recent times, generally been doing all question episodes on the 5th and 10th of the rotation. So next week will be an all question episode. So if you do have a question for us, please send it through via our website, spaceNutsPodcast.com or spacenuts.io. Click on the AMA tab to send us an audio question, or the send us an audio question tab on the right-hand side of the screen. and we'll get through as many as we possibly can, including this one, Fred, which comes from Brett. And this is an area I have an interest in, and I know a lot of people are astrophotographers and get out in the backyard with their telescopes trying to take fascinating pictures of objects that are close enough to see. Brett from Pennsylvania says, I have a question about professional astrophotography from large observatories. So the way I've been learning to take images is through what's called the prime focus with a DSLR camera or a focal with a cell phone. What type of technique do large telescope observatories use? Is it like prime focus DSLR or with a built-in camera? Thanks for taking the time out of your day for my buffoonery. Love the show. Have a great day or night or whatever it is when you read this. Well, I actually read that at 9:15 Eastern Standard Time yesterday morning. Okay. So, Brett, thanks for the question. I've never thought about it, but are the techniques used by those big observatories similar or the same as the ones like, do you strap an SLR camera to the bottom of your 4-meter telescope or whatever?
Look, it is a great question. And there are really strong similarities between what astrophotographers do and what professional observatories do. But I guess the thing to remember is that the cameras that professional astronomers use, and they're since the 1980s, they've been CCD cameras, charge couple devices. And they're the ones that really led to the development of, the consumer level cameras. So these were pioneering instruments. And in their most basic form, and this is still what they look like, they consist of a chip, a silicon chip, which has the charge wells etched on it, which is usually cooled, because if you don't cool them, they basically all you get is thermal noise. You get the heat noise from the detector. So they are placed in a thing called a cryostat, and the cryostat is, as you might expect from the name, something that keeps it cold at a particular temperature. The ones I used to use were cooled to about minus 100 degrees Celsius.
Whoa.
And that's so that you can do very long exposures. Typically you can do 20 minutes, half an hour or something like that, before the thermal noise, the noise coming from the sheer temperature of the thing, before that gets too excessive. So they're cooled. We cooled them often with liquid nitrogen, but also with what are called cryo coolers. These are like very sophisticated refrigerators. So, but stepping up to state of the art, today it's the same sort of thing, which is essentially a box with a big window on the front, and that box is evacuated. You've got to get all the air out of it, because otherwise the air transmits the heat from the outside to the detector, and it's impossible to keep it cool. So it's in a vacuum. It's cooled by either liquid nitrogen or as I said, a cryo cooler, something that actually acts like a refrigerator. But often today, these things are not just one silicon chip. They're a mosaic of silicon chips, sometimes with more than 100 individual detectors. And so what you do is you build up a mosaic of these detectors that allow you to cover a much wider area of the sky. And that is often at prime focus. That means the main focus of the mirror, but sometimes they're used at different foci as well. Often there's a corrector lens in front of them as well. We used to have, when I started this game using CCD detectors, I was doing it, Andrew, for spectroscopy rather than direct imaging. I was putting the detector behind a spectrograph, so it was recording the spectrum of objects rather than just the individual objects themselves. And we had all kinds of problems with some of the glasses that were used in the correcting lenses were just slightly radioactive. Oh. And so they ping out all these subatomic particles, which of course are recorded by the detector that's about 5 millimeters behind it. And so that was a big problem. We wound up having to use fused quartz, which is pure silica as the lens material. There's also one of my favorite stories in the story about astronomers' acronyms, because astronomers always think up fancy acronyms for their instruments. I built several with slightly more and more ridiculous names. First one was FLAIR, the Fiber Linked Array Imagery Formatter. Anyway, the story goes on. But my favorite of all time is one of these mosaic cameras that was being built by a group in the USA. And they were going to call it Mosaic, which was an acronym. And I can't remember what the acronym was for, but it was going to be called Mosaic, this instrument. But then they realized that somebody else had an instrument already called Mosaic. So they renamed it TIFCAM, which sounds very appropriate because it was a camera. TIFCAM is an acronym for the instrument formerly known as Mosaic, which I thought was just brilliant. And so TIFCAM, became a bit of a thing.
The artist formerly known as Prince.
Yeah, that's right. Yes. Yeah. Yeah.
Oh, that's just too good.
Yeah, it's a nice one, isn't it?
Yeah.
So so it is similar technology. Just one other thing, that the detectors that are used in the kind of imaging that professional astronomers use are not color detectors. That means that they're not a mosaic of 3-color charge wells, which a commercial one would be. The color is put in by filters that are put in front of the camera. There are different ways of doing it. You can actually divide the beam up through different colored filters. So you've got maybe three cameras all recording black and white, but looking through 3 different colored filters, which you can then build back to get a true color image, a real true color image. Or you can do it successively by having a filter wheel where you put a different filter in front of the camera and take separate exposures.
So in answer to Brett's question about, do you use an SLR camera, that would be a no?
It's no, that's right. But it's not that dissimilar. Yeah.
Okay. What sort of camera would David Malin have used because he's famous for his astrophotography?
Of course, that's right. Well, he used something called photography. He used plates and actually...
Oh, plates? Wow.
Yeah. Well, we did. Photographic plates were the stock in trade of astronomy until actually, certainly for large format cameras, and that was what the UK was. We were using them until 2000, in fact. I think our last exposure, which was probably made on film rather than plate, was 2003. These were 14-inch square glass plates, 356 millimeters or whatever it is.
Yeah.
Because you couldn't get electronic detectors of that size. That's why photographic plates were used. So yes, David's techniques were all perfected. Towards the end of his career, he was using CCD cameras, charged a couple of devices, but he retired in 2000. So photography was very much what he did. So he was a chemist, actually. That was his background, and it was the chemistry of the photographic process and the idea of using colored filters that launched him to fame in the 70s and 80s.
Yeah. Oh, look, if you've got time to look up David Malin's photos on the internet, they're all over it, because some of them are just famous. You'll recognize them as soon as you see them.
They were on book covers and record covers now. And now amateur astronomers can produce the same quality in terms of the color because of all the software, clever software devices.
Well, most should say I'm not one of them. I'm still practicing.
Yeah, David's, we catch up usually about once a fortnight, once every 3 weeks, because he lives quite close to where I live here in northern Sydney. So we're they're often around here and we're often around there. It's very nice to have a friendship with one of the great icons of Australian astronomy.
Well, pass him my regards. He doesn't know me from a bar of soap, but do it anyway.
I'll tell you about it. Don't you worry, I'll tell him about you, Andrew.
Yeah, I'm sure you will. Yeah, I don't think I like that. Okay, now thanks, Brett, for your question. Hopefully that answers your query. Now let's move on to an audio question. Fred and I think that this has been a sort of a wake up at 2:00 in the morning. Oh my God, I need to know the answer to this question. It's certainly not something that I've puzzled over, but Fenton definitely has.
Hi, Fred and Andy. This is Fenton, and I'm in Minnesota, in other words, in the US, on the opposite side of the planet from you. I saw a poster presented by someone at NASA who was talking about the ratio of hydrogen to deuterium as a function of distance from the sun. And it apparently changes. There's a gradient. And I don't even know which way it goes. And so if you could talk about this, maybe explain which way it goes, what the theories are behind it. And if you have time, I would also be curious to know if there are different ratios of other elements as we travel away from the sun.
Ah, wow. Okay, Fenton. I don't know. Honestly, we are so surprised by some of the things people think of to ask, and that one I would never have anticipated in my life. The ratio of elements as you move away from the sun. Of course, the answer is it increases in terms of deuterium and reduces in terms of hydrogen. I thought, I knew that off the top of my head. But it's a great question. I mean, all the questions are great. Yeah. But this one's way out of left field. I was not ready for it.
No, and it's absolutely true. So you're quite right, Andrew. The ratio of deuterium to hydrogen increases as you go out through the solar system. So of course this sent me to the Webb to check up on the background of these observations. So there's some results that ESA, European Space Agency, reported at the end of 2014, and they come from the Rosetta spacecraft, which was capable of observing, well, of course, the comets 67P, Churyumov-Gerasimenko, the one it went in orbit around, but also to look at other, the other work or other sources of our knowledge of what deuterium to hydrogen ratio is. And I'm going to quote actually from this ESA article, because that's the easiest way. Otherwise, I'll just gobbledygook all the terminology. But this is just a news report from ESA back in 2014, and it says the different values of the deuterium to hydrogen ratio in water observed in various bodies in the solar system. That's what their result is. Deuterium is an isotope of hydrogen with an added neutron. The ratio of deuterium to hydrogen in water is a key diagnostic to determining where in the solar system an object originated and in what proportion asteroids and/or comets contributed to Earth's oceans. And that's why this is such an interesting thing. So you can't see the diagram, but I can tell you the data points are grouped by color as planets and moons, which are shown in blue, chondritic meteorites from the asteroid belt, which are in gray, comets originating from the Oort cloud, which are in purple, and Jupiter family comets, which are in pink. Rosetta's Jupiter family comet, that's 67P, is highlighted in yellow. Sorry about that. No, you can't see any of that. But what it's saying is it's showing how, and just to describe what this diagram shows, it's a gradual increase from the Earth, which has a deuterium to hydrogen ratio of around about 10 to the minus 4. That's 1 part in 10,000. So that's where the Earth is. But as you go further out in the solar system with these various Jupiter family comets and the Oort cloud comets, as well as 67P, you find that the ratio gradually increases. And 67P itself has a ratio of, reading from the diagram here, it's about hang on, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's 4 times 10 to the minus 4. It's rather more than the Earth is. So that the difference is not great, but it is there. And that's, I guess that's what it's telling you, is that the fact that the ratio of deuterium to hydrogen is higher, it's the consequence. I'm just going to go back to the article. So actually, this article is very much along the lines of it's not giving us a reason why the ratio is higher. What it's just saying is that that's the fact of the solar system, that you've got more deuterium out in the in objects that originated further out in the solar system, and it's just basically telling you the fact that in fact, I'll quote, the discovery fuels the debate on the origin of Earth's oceans and whether asteroids or comets played the bigger role in delivering water. So the fact that 67P has more than 3 times the ratio of deuterium to hydrogen as the Earth's ocean did, that says, well, maybe our water didn't come from comets like that. But some of the nearer ones have lower deuterium to hydrogen ratios, and that suggests that perhaps they did. So a complex but very interesting question. And whether other elements are certainly present in different ratios as you go out. You've got far more hydrogen in the gas giants than we have locked up in the Earth. So that's the sort of latter part of Fenton's question.
I suppose it makes sense that Earth's oceans have less deuterium than some of the objects in the outer solar system, because I think you and I discussed not so long ago a study that suggested Earth's water probably came from the rock itself, which contained water when the planet congealed.
That's right. So yes. So I think that the answer is that it's a mixture. It's there is some water that's come from comets with a higher deuterium ratio, but there's also a kind of high population of indigenous water that came, as you say, from the rock itself. It was locked up when the solar nebula collapsed and the rocks were formed. It's fantastic stuff.
And they've been able to, from that data, prove that the amount of water on Earth is accountable, whereas comets alone couldn't have done it.
Yes, I think that's right too. You're remembering our stories well, Andrew. Yeah,
sometimes I do. Yeah, and when I was at school, all the stuff I remembered never came up in tests.
Oh, that's no good.
It's only the stuff I forgot.
Did.
That's my excuse, and I'm sticking to it.
Well, yes. Yeah.
Now, a reminder that next week we will do a full question answer show. So if you would like to send us a question, if you have a data poor field that you would like us to fill for you, send us your questions via the Space Nuts website, spacenutspodcast.com or spacenuts.io. You'll end up in the same place either way, and you can click on the link on the right-hand side of the homepage that says send us your voice message, or you can click on the AMA tab up the top where you can send an audio message or audio question or a text question. So either way, happy to tackle some questions on next week's episode 310. And while you're online, check out all the other stuff that's happening on our page. You can check out Astronomy Daily, which publishes very regular and up-to-date astronomy news. You can visit the Space Nuts shop. And I just got a message from Hugh to say that somebody who's listening live today on Facebook has just bought a copy of the Turanian Enigma, turned up in the mail. So I will take my 20 cents of commission from that sale and put it in my piggy bank. So thanks for buying it. I hope you enjoyed it. Let me know what you think. I love the feedback. I'd like to know, because the Turanian Enigma's got a couple of massive twists in it. So and so far nobody's written to me and said, "Oh yeah, I picked it." So I like to keep them guessing. But yes, jump on our website. There's all sorts of things to see and do there. Don't forget the social media as well. Space Nuts Facebook page and the Space Nuts podcast group Facebook page, where listeners can get together and chat amongst themselves and share their photos and all sorts of things. It's a great little group, which I pop in to see occasionally. Fred, that brings us to the end of this episode. Thank you so much.
Great pleasure. Always good. Some really interesting stuff. I mean, I learn as much as anybody else does when we do these sessions. It's great.
It happens that way sometimes, doesn't it?
Yeah, it does, doesn't it?
It enriches our data poor fields.
That's what it is. It's all about enrichment.
Yes.
Thanks a lot.
It's another way of saying we've learned something.
Yes.
All right. We'll catch you next week, Fred. Thank you.
Sounds great. Yeah.
Fred Watson, astronomer at large, who helps us out every week here to a minor degree on the Space Nuts podcast. And thanks to Hugh in the studio for pushing all the buttons, ringing on the bells, and making all the coffee and tea. He drinks it himself because he can't get it to us, but he does it anyway. And from me, Andrew Dunkley, thanks so much for your company. Look forward to you joining us again on the very next episode of Space Nuts. Bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
And thanks to those who've listened or watched live. We'll see you next week. Take care.